Let's solve this question. A car starts moving rectilinearly, first with acceleration omega is equals to 5 meter per second square. The initial velocity is equal to 0, then uniformly and finally deaccelerating at the same rate omega comes to stop. The total time of the motion equals to tau is equals to 25 seconds. The average velocity during that time is equal to 72 km per hour. How long does the car move uniformly? Okay, let's find out. So first of all, let's picture this. So something starts here, it is moving rectilinearly in a straight line. So from here it will reach till here with the initial velocity v is equals to 0 and acceleration is equals to 5 meter per second square. Okay, so it will cover this distance, and then for some time it will be a constant acceleration, a is equals to 0, and then during this time it will deaccelerate. Okay, so acceleration will be equals to minus 5 meter per second square, and finally the velocity will be equals to 0. So this is the situation. Total time taken, the whole time of this journey is equals to 25 second, or average velocity is given as 72 किलोमीटर पर आवर. इसको हम मीटर पर सेकेंड में कन्वर्ट कर सकते हैं, विच इज़ इक्वल्स टू 72 मल्टीप्लाई बाय 1000 meters divided by 3600 seconds. So from here we can find out that the average velocity of the whole journey is 20 meter per second. Okay, and total time is given as 25 second. Okay, now let's find out. So total time is 25 second. Let's take, it will take time t from this point to this point, and as we know that if we are starting from zero velocity and with an acceleration, the time taken by the journey is equals to the same as, like, if we are starting with some velocity, same velocity, if we are starting with the same velocity and same deacceleration, then eventually reaching to 0, so it will also be time t. So it will take time t from here to here and here to here. So this time in the middle will be 25 minus time t, sorry, 2t, this t, and it will be 25 minus 2t. Okay, so now let's use our uniformly accelerated motion equations in the first scenario and find the distance, and then find the distance traveled during this time and find the distance traveled during this time, because we know that the average velocity is equals to total displacement upon total time. So if we will find the total displacement in the form of t, then we can easily calculate this t, and then finally we can calculate this time as well. And we know the average velocity, we know the total time, so all we need to find the total displacement in terms of this t. Okay, let's find out. So in case 1, v is equals to 0, initial is equals to 0, so v final is equals to a times t, and a is 5 meter per second times t. From here we can say s is equals to u is 0, then half at square, that is 5 and t square. Okay, so we don't even have to write this equation. This equation is sufficient, as this distance is in terms of time t. Okay, now during this time we know that it is constant acceleration is 0, so we can directly write it in the form of, like, we know the velocity here. Okay, so the velocity here is v final, which is this same velocity. So distance will be equals to s distance 2 is equals to velocity final, this one, times the time 25 minus 2t, and we can write this velocity as 5 times t. Okay, if I mean, this formula is also useful now. So s2 is equals to 5t multiplied by 25 minus 2t. This is our second displacement, or we can solve it further. Actually, s2 is equals to 125 t minus 10t square. Okay, and then the distance traveled during this time will be so our initial velocity in this case is vf. Okay, so s3 is equals to initial velocity is vf, which is 5t, and then multiplied by t is t square plus half a t square, and in this case the acceleration is minus negative, so we can say minus half multiplied by 5 t square, which will be equals to s3 will be equals to 10t square minus 5t square upon 2, which is s3 is equals to 5t square upon 2. And you can see that this distance is equal to this distance. They both are distance are equal, so I mean, it will travel the same distance during this time. Okay, so now finally what we can do is we can find the total distance, total displacement, which is equals to 2 times this, which is equals to 5t square, and then plus 125t minus 10t square. Okay, and what it will become? It will be 125t minus 5t square. This is our total distance. Okay, so now we can apply our formula. The average velocity is equals to total distance 125t minus 5t square upon total time is 25 seconds. Yeah, so 25, and we know this velocity, average velocity is 20. So from this we can calculate 125 t minus 5t square is equals to 20 multiplied by 25. So you can divide the whole equation by 5 and you will get, this will cancel, it will be 25, it will be 5. So basically it will become, this equation we can rewrite it, t square minus 25t plus 100 is equals to 0. From here we can solve this quadratic equation and find out the values of t. So we need to find a multiple such that the addition of which is 25 and the multiplication is 100, which is 20 and 5. So t square will be t square minus 20 t minus 5t and then plus 100 is equals to 0. We can take t square common, sorry, t common, and we are left with t minus 20 and then t minus 20, and you can say minus 5, and which is equals to 0. So we have factorized it as t minus 5 and t minus 20, which is equals to 0. So t will be equals to either 5 or 20, right? So these two values we got, we need to decide which one is true. So basically this cannot be true because the total time is 25, and if this this alone is 20, then definitely like it will be 20, it will be 20, it will be 40 seconds. So it cannot be true. So the true value of t time is equals to 5 seconds. Okay, so if this is 5 seconds, then we can find out the time taken during this, when the car was moving uniformly. So we need to find the time period during this duration. Okay, so which is 25 minus 2 times t. So our final time will be equals to 25 minus 2 times what we got in here, the value of t, which is 5. So t is equals to 25 minus 10. So t is equals to 15 seconds, which is our answer.